In 1654, the French mathematician Pierre de Fermat wrote a letter to his colleague Blaise Pascal detailing a set of theorems he had discovered. Among these discoveries was his assertion that he had devised a general method to express prime numbers of the form 4k plus 1 as the sum of two squares, using a technique known as infinite descent. Fermat wrote, "If a chosen prime number, which is 1 greater than a multiple of 4, were not the sum of two squares, there would be a prime number of the same nature smaller than the one given, and after it a third, etc., descending infinitely until reaching 5, which is the smallest of all of this type, from which it would follow that it is not a sum of two squares, although it is, from which it must be inferred, by deduction to the impossible, that all integers of this nature are, consequently, sum of two squares." Here you have a small list of the first prime numbers 4k plus 1 decomposed as sum of two squares. The big question is, why does sum of two squares matter? Well, it shows up in number theory, geometry, physics, video games, and cryptography. Historically, it appeared as early as 1500 BC in Babylonia as solutions of the Pythagorean theorem, which was independently discovered in Egypt, Greece, India, and China. It was used not only as an academic curiosity, but also as a practical tool for distance measuring, farming plot, and construction of buildings. Most importantly, the story of sum of squares is something that historically spans along 3,000 years, from the Pythagorean theorem to Maxwell equations and even further. In Einstein's special relativity, the Pythagorean theorem plays a central role in time dilation, length contraction, and even energy-momentum relation. Sum of two squares first show up in the Pythagorean theorem. Then, Fermat found that primes 4k plus 1 are sum of two squares, and that all integers are sum of four squares, which were later proved by Leonhard Euler. Based on the sum of four squares, William Hamilton later developed the quaternion number system, which are complex numbers applied to mechanics in a three-dimensional space, which nowadays are sometimes used in video game graphics. Quaternions introduce several key mathematical concepts that are foundational for the mathematical structure and physical understanding of Einstein's general relativity, providing early insights into higher dimensional algebra, non-commutative structures, and rotational transformations. These are the main sum of two squares identities that are used here to get the sought-after solutions. Brahmagupta's identity, where the product of two sums of two squares is also a sum of two squares. Pythagorean theorem, which is just a special case of Brahmagupta's identity, but which was found way earlier. And Fermat's little theorem and Euler's criterion, where p divides a raised to p minus 1 minus 1, and where p and a are coprimes. That can be factored into two cases, where when a is a quadratic non-residue of p, then a raised to p minus 1 over 2 plus 1 is divisible by p, and thus p divides a sum of two squares.